Is everyone in good spirits? There isn't the usual coughing and hacking. I appreciate that. So folks, the good student in the class should be regularly going to our class page to see what's piling up. You've had lecture 2 here for a week. Homework 1 appeared Monday night. Out of respect for you guys, I actually wrote it down and posted it. And I hope the nerds in the room have already done it. My son's already solved it. Someone had to check the answers. And of course, a reading for today was already here. And you guys should be going to this page. I shouldn't have to be texting you like your mommy every 8 minutes. Are you wearing underwear? I'm not going to do that. It's your job as men and women to go to this page. Go to this page on Saturday night. See what the old weird professor has posted. The tortoise wins the race. So folks, let's start with something interesting. Since The Economist magazine regularly talks about me, I read it. We talked about on Monday that there's no free lunch. What did the professor mean by that? Can somebody remember? Has everyone forgotten Monday? What did we mean by no free lunch? And why does that matter in environmental economics? Tough group. Yes?
There'll always be opportunity cost.
There'll always be a cost of everything. And so let's do a specific example, since you guys are sleepy and just want to waste time. But time is the only thing I don't have. I've been given everything else. Here's something in The Economist magazine. Folks, let me hear something righteous. Do I have some environmentalists in this room who hate coal? Can somebody throw a punch at coal? Let me see a punch. I see everyone exercising on campus. A little taekwondo from someone. See everybody jogging and happy. You go away. Pop-ups. Another thing I hate. Look, see? It's good to be feared. Let me hear some righteous environmentalists in this room. Now I'm going to get very angry. Folks, can somebody do something? Today was going to be great if we can't defeat the pop-ups. Folks, somebody say something mean about coal. What negative externality is caused by burning coal? Air pollution, both particulate matter. Michael Greenstone of MIT has argued that millions of Chinese households are dying from PM 2.5 in the colder parts of China because they're burning coal. Folks, do the Chinese just like to die in dirty air? If coal kills, why are they burning the coal? It's cheap. With many products that we're going to talk about, there's short-run benefits from burning coal, but perhaps long-run consequences. Folks, I want to talk about Appalachia, which is pronounced Appalachia. Is anyone from West Virginia? Do we have any diversity at UCLA? So Appalachia is some place I've flown over. We're being videotaped. It's a place. It's a series of poor states. It's West Virginia, and it's parts of the Northeast and South in the United States. Folks, this is a bumper sticker on someone's car. Can everyone read with the professor? Read these 6 words, 7, 8 words. Thanks to coal, I can pay my bills. Exclamation point. I'll read it to you again, since I don't think you understood it the first time. Thanks to coal, I can pay my bills. Folks, what is this Hummer driver saying? And why do I bring this up in our discussion of no free lunch, my liberal environmentalist friends? They can't hear you. These are coal miners. Any of you watch Coal Miner's Daughter? Who is that? Sissy Spacek? Anyone want to hear me sing so I can escape this coal mine called UCLA? That was a joke. So folks, if we get rid of coal, and I actually do think we should get rid of coal, but all actions have consequences. Being awake right now, my bothering to show up right now. I'm working on an important paper. I should have cut class today. I could have cut class today. It's the greatness of being who I am. There'd be no accountability. When you shut down coal, my liberal environmentalists, in your name of stopping climate change, who loses from your righteous action? What's going to happen in West Virginia? What's the point of this article? And so that's the concern. So let me be serious for a moment. All actions have costs and benefits. I support the end of coal. But when we end coal, there will be losers. They're going to be geographically concentrated. Folks, have any of the coal miners gone to UCLA, Berkeley, or Stanford? No. There might be a couple of guys who in the 60s became acid casualties and dropped out of Berkeley and now are coal miners, but I have a feeling none of them went to one of the schools you guys take for granted. So, as she just eloquently said, she said, Professor, an unintended consequence of President Obama banning coal-fired power plants is that there's going to be a spike in local regional unemployment. So if you bother to read this article, here's what you're going to say. Here's what you're going to see. Folks, second paragraph. On September 16th, James River Coal Company stopped production at a mine in somewhere in Appalachia and several others in eastern Kentucky. It furloughed roughly 525 workers. The company blamed continued weakness in domestic and international coal markets. So folks, if President Obama, if we switch to natural gas for producing our electricity, and if we ditch coal, what does that do to the demand curve for coal? It shifts it in. Does anyone understand? As purchasers of coal want less coal, producers of coal, profit-maximizing firms that produce coal, what are they going to do? So you own a bunch of coal mines. You used to send guys down into the mine. Here, walk with me. Do I have to make everything? You see me walking down into a mine? I take my shovel. I shovel the coal. I talk to the dudes. We get all black from dust. We get paid well for this horrible work. We come out of the mine and we go home and we drink. Not a bad life, a little bit like mine. Folks, what has happened to that way of life because of you liberal environmentalists and me? What have we done to that worker? What have we done to these 525 people? We put them all out of work. Does everyone understand? Do I have to get into any of your faces? Now, do I have any optimists in the room? I'm the most optimistic man in America. You folks are yawning at these 525 people. What if they go home and beat their children? What if they shoot themselves? When something traumatic happens, like a loss of a job, how do families cope? What if these guys can't make their mortgage payment anymore and they default on their home? What if all these neighbors in the community default and then the bank goes bust? Do we owe these people anything? Or is this just free market capitalism? So is California going to lose from banning coal production? How many of you are from California? Whoo, diverse. Do you suffer at all from President Obama's mandate that power come from natural gas, that there be no more coal-fired power plants? Folks, who bears, this is called bearing the incidence. For any of you who have taken a course in public finance, when we pass a new public policy, who pays for it? There's no free lunch. So folks, are these folks victims, or were they part of the pollution and are they getting what they deserve? Let me hear you. You're the next generation. I'm old and slow. This would be a good final exam question that I could give you all a 0 for. What would you say, smart ones? Going to look this up in Wikipedia? Victim, coal. Woo-hoo. Let me hear something smart. Yes, and speak up. They can't hear you. They can't hear you in back.
I don't think it's that easy just to blame them.
Too vague. What are you going to do? Are you tough love on these 525 people? I'll ask my question a different way so I can get an A answer. When would you not be worried about these 525 displaced people? If UCLA fired me tomorrow, what would I do? There's 100 universities that would hire me. And so I want to be fired tomorrow. It's all, life is a question of opportunities and choice. Do you have options? If my wife leaves me, there I've got problems. Folks, if you're one of these 525 workers, what can they do to get back on their feet?
Well, what if, so they're trying to switch to natural gas? What if natural gas factories will relocate into that area?
So that's an excellent possible answer. I have a young optimist in the front row who said, Professor, for the 525 now unemployed workers, they could make an easy transition in the green economy if natural gas could be produced in Appalachia and if their skills are transferable. So let's do things, so let's build on her answer. Folks, did everyone hear the economics of what she just said? She said, Professor, If the 525 workers don't have to migrate to a new geographic area, if there's new jobs in Appalachia which use their skills, they could make a relatively easy transition. But folks, somebody tell a nightmare story about the future of these 525 people. Just turn all of that on its head. When would you feel very sorry for them? Yes?
If they can't move, then there is no natural gas in Appalachia.
And what if natural gas requires an ability to do computer programming or some skill? These guys know how to walk into a pit, put down a shovel, and suffer. That's manly. I think they're all guys. But it might not transfer into Mark Zuckerberg's organization. Is anyone with me? So a very important issue is when you're 47 years old and your skills are no longer demanded, can you turn into something new? You guys at age 20 to 22 can recreate yourselves. Part of being at UCLA is this option value of what opportunities you have open. But because we have chosen to make this transition from dirty coal to cleaner natural gas, folks, are these guys victims? I was about to use the word victim. How many folks view these 525 as victims of change? For those who say that they're not victims, why? Because you can argue it both ways.
I mean, I think anyone who's losing their job is a victim in the sense that you have to adapt to the new economy.
So a point we're going to talk about throughout these lectures is the following. If you were one of these 525 men, would it be in the back of your head, remember we contrasted Mr. Spock and Homer Simpson? A Mr. Spock might have said to himself, I've got a good paying job right now. I'm making 25 bucks an hour. I've got health insurance, but there's a 12% probability that this industry could go under. If you anticipate that there's a positive probability that you could be fired from the coal job, what might you do to protect yourself and your family? You always have choice, folks. What choices might a rational, forward-looking worker in a dirty industry, what investments might he choose to invest in? Could go back to school, that's human capital. What about his asset allocation if he had some money? What portfolio would he be holding? Could invest in green companies. That would be a way to diversify risk. Is anyone with me? These guys have sort of put all their eggs in one basket. Their home is in Appalachia. If coal demand shrinks, then the home price is going to fall, and they've got their job in dirty industry. They've sort of bet everything, like a roulette player, they've bet everything on the dirty industry. They're not holding a diversified portfolio. As Jim Tobin said when he won the Nobel Prize at Yale, the intuition of my life's work is don't put all your eggs in one basket. You're supposed to laugh. But that's what diversification is. The lack of diversification, you're undiversified if you put all your eggs in one basket. So are these guys victims? It's interesting. Now, if you're President Obama and you're supposed to care about these folks, what's President Obama going to do for the people of Appalachia? So does everyone see that Californians bear no cost from voting against coal. It's a free lunch for California. We reduce greenhouse gas emissions, and none of us are dependent on the coal industry. It is true that Los Angeles Department of Water and Power's prices are high because of coal, but we're going to learn that the hard way. I encourage you to read this article. If you were President Obama and you are worried about Eastern Kentucky, what do you do? Do I have any benevolence in this room? So should the people of California pay higher taxes to collect money to give higher unemployment insurance to the people of Appalachia? How many of you vote for that? I might vote a little bit with that, but you and I, so we've got a bunch of cheapskates here. So folks, what could President Obama do for these folks? We've got 525 unemployed people because of us. An unintended consequence of our banning coal is we created this unemployment during an ongoing recession. Aren't all of you folks the devil? Or is there no free lunch? Does anyone understand what I'm saying? These are the issues where economists step in. But 2 more minutes, if I have any political science majors in the room. You're President Obama, and you want everyone to live the American dream. You've just inflicted pain in a specific geographic community, Kentucky. Do you owe these people anything? Or do you send them a signed picture of yourself? What do you do if you're President Obama? Do any of you think? What do you do? Be a good exam question. Got 3 seconds. You.
I think President Obama should give support for their life during a period of transition and provide some education opportunity for them to develop skills for other jobs. And after this period, then they will do something for themselves. without government.
So Bill Clinton, when he was president in the 1990s, pursued his vision of retraining workers whose industries had declined. Where he is correct is for younger workers that will work. But for 47-year-old workers, can I be retrained? I'm noticing that I'm becoming more and more an inflexible thinker. I actually need to be around young people more to help me to think. I become locked into my ways, and I have a PhD. And so I'm with you, but there's a worry in labor economics that as people get older, they become harder to retrain. Folks, other policies you would engage in? Yes?
Can you say that for anyone, because any older person no matter the industry, that they're finding that they're being replaced by younger generations that don't have the skills to go somewhere else?
So then in that case, I agree with you. That would take us to a different course on demography, but I would be happy to talk about that issue in office hour. That gets into intergenerational fights, and I think we should talk about that outside of class, but that's a very important question. Folks, I want to make one extension of his point. An unintended consequence. Suppose President Obama said, I'm going to give everybody in Appalachia $1,000 to help them get back on their feet. Folks, what would be an unintended consequence of that righteous policy? We'd have to pay for that. Folks, your tax burden, so you would multiply $1,000 times the number of people in Appalachia and divide that by the total number of taxpayers, and that would be the taxes each of you would pay. But what's an unintended consequence of a spatial transfer to Appalachia? Do we want people to remain in Appalachia? Is it a productive place? We actually want them to get the hell out of there. If you want to help the people of Appalachia, do you send money there or do you send bus tickets there? So after the horror, you were supposed to laugh, but there was an idea there. Did anyone understand what I said? After Hurricane Katrina in New Orleans, Ed Glazer of Harvard was asked, how do you help the people of New Orleans? The mayor of New Orleans wanted a $100 billion check to rebuild New Orleans, and Ed Glazer said, give everyone in New Orleans a bus ticket out. Think about it. And so there's a question of whether an unintended consequence of transferring money to an unproductive place is to keep potentially productive people mismatched to the wrong place. Migration is a way to allocate scarce resources, human capital, to productive places. It can be the case that an unintended consequence of government propping up an unproductive place is to slow down the transition. So this occurred in Germany after communism. When East Germany and West Germany merged into one nation, rich West Germany started to transfer money to East Germany. Robert Barrow of Harvard argued that this was a bad idea. It was good for the heart, but it would keep East Germans in East Germany when it would be more productive for them to migrate to West Germany to more productive cities. Does anyone understand what I'm saying? There's no free lunch, and all actions have unintended consequences. If you understood what I just said, you can now take the final. Please read this article. Everything we do is relevant for the real world. And now let's do some hard stuff. Good. Folks, I didn't say this in the first class, and I should have said this. Economists have a very pretentious goal, which is not hypnotizing students and showing that we could have been PhD mathematicians. The job of modern economics is to explain and predict all human behavior with a very simple incentive model. We talked about incentives last class when we talked about your incentives to go to UCLA. If UCLA had lower tuition, if we had better football team, if there was better dating, these would all be incentives to come here rather than Berkeley or Stanford. Different people will respond to different incentives. The rational choice is that an individual or firm knows their objective and given their choices, makes that choice which is best for them. An unemployed coal worker in Appalachia will choose where to live, comparing her utility from remaining in Appalachia versus moving to Las Vegas or San Francisco. Folks, as you're going to see in homework 1, everything we do has an empirical focus. We're a little bit like Sherlock Holmes. We're going to observe a crime scene and we're going to try to figure out why it occurred, as we'll talk about in detail today. As we talked about last time, environmental economics is a branch of microeconomics with 3 new features that you did not really discuss in your microeconomics classes. There's going to be externalities. Let me hear everyone say that word. Not very enthusiastic. Louder. Do we have to do an 8 clap? So folks, we're going to do Blinky the three-eyed fish from The Simpsons is a famous example of an externality, and we're going to spend the whole class on this. Does everyone remember my yelling about how dirty public parks are versus your living room? That's the distinction between private property and public property. By public goods, I mean the following. Suppose that there's a beautiful bald eagle flying over UCLA. That's a public good that we can all enjoy it simultaneously. We can all look up in the air. Kobe Bryant's a public good. We can all watch him play basketball. We can all watch the eagle fly and enjoy it simultaneously. That's very different from a cheeseburger where if I eat it, you don't eat it. So many goods are private goods, but other goods are public goods. If there's a bald eagle flying around UCLA, we can all enjoy it. There's going to be a fascinating free rider issue of who pays for that bald eagle's food. So folks, let's do this quickly since you're yawning at the professor. Suppose the bald eagle needs $15 worth of food each day. Who's going to pay the 15 bucks for the bald eagle? If there's 30,000 of us enjoying the bald eagle. If each of us just paid a penny, 30,000 times a penny, I believe is $300. Folks, are we going to collect that penny from everyone? What's a free rider going to do? Give nothing. Why are you such a bastard? What was your logic, bastard? Why could you get away with it? Was that in English? What did you say? It was a correct answer, but what did you say? So what's your logic? You're small. But in symmetric logic, you say to yourself, a penny's a penny. If I don't pay that penny, these other suckers will pay for the bird and I'll have my penny. But if everyone thinks like that, how much money is collected? Zero, bird dies. That's the free rider issue. You just killed the bird. If there had only been one of you, how would you have thought about the bird's food? You would have said to yourself, this bird's cute, but do I want to spend 15 bucks a day on its food? If you value its existence at 365 times 15, you'll pay for its food every day for a year. Does anyone understand? There's private versus public goods, and we will make this distinction over and over again. In conventional microeconomics, I want to contrast why this field is so much more exciting than boring microeconomics. In boring microeconomics, there were these consumers, think of Starbucks, who go to the market. They know what they want. They are utility maximizers. They buy market products like sneakers and cappuccinos to make themselves happier. They are the demanders of products like cell phones, purses, wallets. There are firms who are profit maximizing who produce these goods and in markets sell them to these guys. In equilibrium, everyone make the supply and demand X to me. In equilibrium, a price pops up where supply cuts demand such that aggregate supply equals aggregate demand, and there are gains to trade in this market. So folks, again, the price of a Starbucks cappuccino is $3.35. I wish it was zero, but I'm still willing to buy the cappuccino. Starbucks would love to collect $500, $5,000 per cappuccino, but because of competition on both sides of the market, the equilibrium price of a cappuccino works out to $3, and there's gains to trade. Folks, why don't I make my own cappuccino? Why am I such a sissy? Why do I let that barista or barrister, whoever they are, make it for me? And many of my students work at Starbucks. I am hailed when I walk in. Why don't I make my own coffee? Because it takes time. And I prefer spending my time in office hour with my precious students. And so there's always an opportunity cost. Starbucks has a comparative advantage at making good coffee. If I tried to make a similar cup of coffee, it'd probably take me the rest of my life. And so I subcontract to them. So in cities, you can trade with all these people in all these different fields. If you lived alone on a desert island, you would have to, anything you consume, you'd have to produce for yourself. Cities and capitalism go together as you focus on what you're good at, giving bad economics lectures, and you contract through markets for everything else, whether it's dry cleaning, cooking, pay people to be nice to you. There's all these markets. Oh yes, this is important also. In conventional microeconomics, there's a market for everything you want. Folks, somebody name a market, a funky market they recently participated in. Something rated G, please. Want to look up my Wikipedia definition? Is that what you want to do? We back in junior high? Somebody give me a market they participated in. You.
I bought tempeh.
Well, I don't even know what that is. But good, that's funky. Is that a toupee?
No, tempeh. It's a fermented soybean.
All right. Well, bring that in. We should try that. All right. So that falls in under here, like cream cheese or light beer. Folks, in non-environmental economics courses, the property rights are well defined. The worker owns himself and can sell his labor to the firm and be paid a wage. Starbucks owns the cappuccino until I give them the $3, and then the young barista hands it to me. Does everyone see the transfer of money for property? Firms own their output until the consumer pays for it. And this is all understood. Now I want to talk about how environmental economics builds on microeconomics. And today my goal is to introduce, through a horrible example, the idea of externalities and social cost. Folks, you run a steel factory, and we're about to do some algebra together, so everyone get ready to be sleepy. You run a steel factory, and your goal is to make money. Everyone's saying money, money, money. Now, the reason you want to make this money is because you have a bald son. And if you make enough profits, you can be the sugar daddy to a foundation that's looking for a cure for baldness. So you're a good person. The reason you want profit is because there's a cause you're passionate about. And that's why you want the profits. Does that make anyone feel better? Everyone say again, money, money, money. Now let me tell you how you make money. And this is like Breaking Bad. You produce steel, which are measured in Q units. So Q is a positive integer, a non-negative integer. If you shut down, you produce 0 units. If you produce 12 units, Q equals 12. Folks, in this perfectly competitive model, you are a price taker. For those of you who have taken microeconomics, this is a horizontal marginal revenue curve. You take the world price of steel as constant, which is equal to P. Everyone say P. You can always go use the bathroom. P could be $32. Folks, if P equals $32, that means no matter how much steel you produce, you can always sell it at the world price of $32. Folks, there's no free lunch. This is important. This is your private cost of production. And don't ask me where this came from. We're just making this up. Your private cost of production, measured in dollars, you have to pay for labor. Folks, here's the whole key to today. The profit-maximizing firm pays for labor in robots, but is it going to pay for its pollution? Everyone together. We pay for labor. We pay for robots. But we don't pay for pollution. So the labor in robots are going to be private costs. The pollution, which is going to be pissed on the society, is going to be the social cost. And we need to solve for all of this. Folks, read with me, and our first algebraic equation. Your cost equals 10 plus 2 times q squared. Notice the following mathematical properties. Whenever your professor gives you a function, graph it. This should be graphed with cost measured in dollars on the vertical axis and tons of steel, Q, on the horizontal axis. Folks, start plugging in numbers. If you produce 0 units of steel, so Q equals 0, what cost do you incur? 10. If you produce 2 units of steel, 2 times 2 is 4, times 2 is 8, plus 10 is 18. The total cost of producing 2 units of steel is 18. Folks, let's do one more. If you produce 10 units of steel, what is your total cost? 210. Folks, does everyone notice that this is a convex function? This is 2 times q to the 2nd power. What is your intuition about convex functions? Is this firm going to produce an infinite amount of steel? For those of you who know calculus, why is this going to have an interior solution? Why is that immediate? Tell me about the marginal revenue and marginal cost to this firm. The marginal profit benefits to this firm of selling an extra unit of steel is it collects this amount of money. Does everyone see that its costs of production are increasing at an accelerating rate? Does everyone see the acceleration here? If this had just been 2 times q, that would have had a constant slope. But from the slope is 4q. The marginal cost is getting bigger and bigger. This firm is going to produce a finite amount of steel, and let me show you exactly how much. So folks, in a boring microeconomics class, the professor hypnotizes everyone, saying that profit equals revenue minus cost. She then plugs in revenue equals price times quantity, the price you sell your output per unit times the number of units. Folks, I've just substituted in the cost function and distributed a -1. Suppose it's the case that by the world market for steel, the price equals 36, Substitute in the 36 for the p. Folks, does everyone see a calculus problem in one unknown? If you don't know the calculus, you could solve this with the discrete calculus in Excel and just search for that value of Q that maximizes this function. Any questions up to here? When I did this problem 10 years ago, it looked like Q equal, the profit maximizing firm chooses to produce 9 units of steel, and then when you plug that into the function and solve for profits, they earn $152. Questions up here? There's been no environmental economics yet. There's just been the boredom of micro. Can everyone boo? Yeah. Boo. So, this is boring. Let's skip this. Now we introduce the externality associated with producing the steel. Folks, an unintended consequence of producing each unit of steel is 2 units of pollution. Whose job at UCLA would it be to measure this thing? This is what these industrial engineers do. Do I have any engineers in the room? Goes on at this place. You're not from Appalachia, you're all from California, and no one studies real things. I already give you the answer here, but let's think about this for a second. Factories differ with respect to their pollution content. Can we all agree that an old communist factory might produce more pollution than a new factory? If engineers make progress over time, an old factory might have worse technology built into it, and this number could be 54 or 55. Folks, a question which is not in the notes. Does this steel factory have any incentive to build a green factory that produces 0 pollution when it produces steel? Somebody use the word no in a sentence and complete the sentence. Why does this company have no incentive to have a green factory? Yes?
No, because they don't have to pay for the pollution.
Excellent. They have no incentive to economize on pollution because they're not being charged for the pollution they create. Folks, does anyone understand? This firm faces a 0 price for emitting pollution. As a business person, if you face a 0 price for emitting pollution, are you going to spend much time or effort reducing your pollution? I don't think so. Let me be serious for a moment. A point we're going to come back to later in the course is about product differentiation. Folks, how many of you have a Samsung phone versus an iPhone? How many of you have a Samsung phone? How many of you have an iPhone? So this is product differentiation. Does everyone see the battle between the products? Suppose that when Steve Jobs was on his deathbed, he said to the world, each of my iPhones kills 3 Bangladeshi children as they make it with their fingers. Would any of you have substituted to the Samsung with that information? Boy, maybe this is not such a liberal room. That's interesting. We will come back to that of how differentiated products compete with each other. But folks, steel is steel. There isn't good steel and bad steel. Well, there is, but I don't want to talk about that. With ice cream or with cell phones, there's a question of the life cycle of the product, of how it's produced. But with an intermediate input like steel, no one's going to know whether pollution was created. And no consumer is going to boycott a product even if they know that there was pollution produced. We're going to come back to this later in the course. Folks, this is related to homework number 1. Ooh, and I forgot to show you homework number 1. Okay. Folks, in homework number 1, you're going to have to think about the relationship. In homework number 1, I give you data, and you're going to be thinking about whether pollution causes sickness. Folks, UCLA has a very strong School of Public Health. Have any of you taken a course at the School of Public Health? I think we have some students from there. So we've got one person. What many epidemiologists do for a living is the following. They collect a data set for thousands of people. So how many of you were sick for 3 days, for more than 3 days last year? How many of you were sick for more than 30 days? It's interesting. So if we collected this data for everyone at UCLA, that's what this variable would be. How many days was each person sick last year? Some have conjectured that pollution causes sickness. What you're going to be thinking about in homework number 1 is when from data can you conclude that pollution causes sickness? Folks, does everyone see? Please ignore this variable u, which I talk about in chapter 2. Does everyone see a linear function relating sickness to pollution? Can somebody say in English to me what beta 1 represents? Not you. Too many correct answers coming from front. The folks yawning in the bleachers, the guys filming. Why am I here? You. Yes, you. Yes, you. Faster. What? That's correct, but that's not mathematically correct. What's the definition of a slope?
If we increase 1 unit of pollution, there will be 1 unit of sickness.
Thank you. That's the definition of a slope. As economics gets harder, we need to be more careful with our language. So what she said was right, but not tight enough. What beta 1 represents is for a 1 unit increase in pollution, that for whatever beta 1 is, we predict from this, if we knew beta 0 and beta 1 represents a parameter of, for a 1 unit increase in pollution, sickness increases by beta 1. Folks, if we had a bunch of supermen, what would be our estimate of beta 1? 0. Pollution is not kryptonite. Pollution has no effect on supermen. For different populations, this is not a law of physics. For different subpopulations, old ladies, minorities, little kids, supermen, fat guys, beta 1 will differ. It's of interest to statisticians to estimate this for different samples. Folks, as America gets stronger, as we eat more meat and more protein, beta 1 could actually fall over time. My wife has worked on infectious disease and how if you have a stronger population who's eating more protein and more meat, you can fend off pollution exposure. So beta 1 is not a law of physics and needs to be estimated in different nations at different points in time, and that's what these epidemiologists do. In the example we're about to do, let's assume that beta 1 equals 0.2. And what this means is that a 5 unit increase in pollution causes the average person to be sick 1 more day a year. Any questions? I'm making this number up right now, but these parameters are estimated, and you're going to estimate these in homework 1 if anyone gets it correct. Yes? Faster, please.
Is the B not the background?
So she is correct. What B0 represents is the intercept. If pollution were 0, then this term is mean 0. If pollution is 0, then the average, on average, what beta 0 represents is if pollution were 0 outside, the average person would be sick B0 days per year. So that is the background under that baseline. Folks, here is some data. I don't want to do your homework 1 for you, or maybe I do. I don't think I do. This is right out of the book. I want you thinking about this. So let me show you what we've done already, because we've already covered some ground. The steel factory, pursuing its own narrow self-interest, produces 9 units of steel. How many units of pollution have been produced? 18. 9 times 2 is 18, my young geniuses. Think. Given our parameters, how much is everyone sick because of the 18 extra units of pollution? You should have immediately seen 0.2 times 18. Faster, faster, faster. Don't waste my time. So what have we calculated? We now know, if you've been thinking by the transitive property, how every person who lives near the factory, how many extra sick days they've been exposed to. Folks, does the factory care? Should we burn the factory's boss? Isn't he Hitler? What's going wrong in this economy? You can still drop this class. I spend a lot of time alone for obvious reasons. I'm very happy there. Yes? So should we shut down the factory? We're going to have to talk about that as well. Life has benefits and costs. But the firm has been ignoring the social costs of its pollution. Folks, we now know how sick everyone is. How much do people suffer from being sick? You guys love being sick. When you're sick, you can cut your class, send your professor an email, I'm sick. All your friends visit you, play your video games, watch your Lady Gaga. It's great. But for other people, when they're sick, they don't get paid that day. And so what labor economists do, and this is a little bit tacky on our part, is we value people's time at their daily wage. This means that if Donald Trump is sick for a day, he loses a lot of money, while a poor person on minimum wage suffers relatively less if you follow this. So this has been very controversial, that economists value people's time by their wage. We can come back to this, but this is a standard thing that economic consultants do in their studies. So Suppose that in our simple economy that the daily wage is $4. And I'm just making up that number. We can now put the pieces of the puzzle together to calculate the social costs or externality associated with the steel plant. Each unit of this specific steel factory's production produces 2 units of pollution. Each unit of pollution causes 0.2 sick days. Each person loses $4 for each sick day. We can now calculate when the steel factory produces 1 more unit of steel, an extra unit of Q, you multiply these numbers together, 2 times 0.2 times 4, and that causes $1.6 worth of damage to each exposed victim from each unit of steel production. Folks are yawning at genius. Folks, what real economists do is we write down very tight mathematical models of exactly what we're saying. Now, I defined public goods before when I talked about that bald eagle and when I talked about Kobe Bryant. The opposite of a public good is a public bad. How many people live in this city? Folks, how many of you know how to use geographic information software? So GIS is a very useful skill. What men and women who know how to use GIS do is they will do something like this. We've got no chalkboard. Yeah. Think of the place you grew up in as a child. Make that a dot on a map. Draw a circle with your house as that center of the circle with a 5-mile radius. Do you have an idea how you would count all the people who lived in a 5-mile radius around your house? That's where this number 500 comes from. Think of the factory as think of the factory as ground zero, as a point on a map, and think of how many people live within a 5-mile radius of that factory. That would be an example of how you could count to the 500 victims. And so what many economic geographers do is they do studies on environmental justice. How many people live downwind of a factory? Folks, a question, are these people victims? We're going to come back to this point. Do I have any free market thinkers who can give a reason why they're not victims? It'd be a good final exam question. Yes?
The reason that they leave around the pollution sources could be that the houses are cheaper, and that's why they choose to live there, and they have to.
Hee hee. So as she said, there's no free lunch. In polluted places, what we're going to talk about later in the course is that home prices will be lower in those places. So some individuals might choose to live in a place with cheap rents in order, we all want a free lunch of cheap rents and low pollution. But in the planet I live on, there's no free lunch. If you want cheap rent, there's going to be something nasty. So a big topic in environmental justice is when you see people living in a polluted place, were they compensated for that with cheaper rents? And if not, why in the heck are they living there? But to keep this example going and to keep your young mind stimulated, let's assume that these folks are victims, that they didn't know what they were being exposed to. We're going to talk about latency and we're going to talk about information patterns later in the course. So there are 500 victims, each suffering this amount of pollution exposure per unit of steel. Folks, here's the calculus for those of you who like calculus. The total damage in dollars caused by the steel factory is the following. This is a partial derivative sign, folks. It's how much extra pollution is produced as the company produces extra steel, multiplied by the increment in sickness caused by extra pollution, multiplied by the dollar damage, where we weight by the wage, the extra sick days caused by sickness, and then you multiply that by the number of victims exposed to this exposure. In the last question on homework 1, this is what you're going to be doing. Wake up, people. Somebody has to get above a C. I need a new Charles. So as we just did, the per capita damage from a 1 unit increase was $1.06. So somehow the 500 people became 5 people. So where did that happen? Oh, bottom bullet point. We assumed there were only 5 people. There's 5 people, each of whom suffers this amount per unit of Q. The total damage is the per capita damage multiplied by the number of people exposed, 1.6 times 5. So this is the important point. These two is the important point. We've now, through this very involved example, we have solved that this steel factory causes, for every unit of steel it produces, it causes $8 worth of damage. Folks, why does this matter to a public policy maker? Why did we do this? And folks, real-world economic consultants do this all the time. Why did we do this? Am I just killing time? I know how many minutes are left in the course. Only class I'm teaching this year. Yes?
So you can factor that into the original equation you gave us about the cost of production, and that money can go to the government to basically offset the social costs of pollution.
This is a good answer. So we've got a young Democrat in our room, and he just said, Professor, from a public policy standpoint, we need to know, from society's standpoint, what are the marginal benefits and marginal costs of letting this steel factory continue to produce? Because of all your boring algebra, you just solved that an unintended consequence of this steel factory producing an extra unit of steel is that there are $8 of social costs. Folks, does the factory internalize this? Has the factory noticed this? These are costs unassociated with labor or robots. These are costs borne by the victims. Folks, can we put the words pollution tax into a sentence? Do I have any young Bill Clintons or Obamas in the room? Yes, we can. Can I hear it?
Yes, we can.
Again.
Yes, we can.
Folks, should the pollution tax per unit of steel be $6? No. Should it be $10? No. It should be $8. By solving for the externality, a free market economist has come up, we as a group, thank you, we as a group have solved for the optimal pollution tax to put on this factory. Folks, in the current pollution tax is 0. Does everyone see that this firm faces no incentive to not produce pollution? We've solved that under these parameters, it's 8. And of course, you can play around with the parameters and get a different answer. So we can now define a negative externality. And let me take a look at the clock. And your last question on homework 1 focuses on this entirely. The social cost of producing steel exceeds the private cost of producing steel. Folks, the private cost of producing steel was that 10 plus 2 times q squared. Here's the important point. As I told you before, if you took a derivative of that cost function with respect to q, the marginal cost was 4 times q. The social marginal cost of producing steel is the private marginal cost, 4 times q, plus the social marginal cost, which is always 8. This firm, yes, we've made that point. Folks, notice how hard, now let me say something about interdisciplinary environmental science. So the Institute of the Environment is all about interdisciplinary science. I want you to notice, and several of you are now sleeping and you're going to get hit by a cane. Professor has a photographic memory, and be careful what you say to me. I'm starting to memorize your faces. We need to know all of this information to make progress. We need to know from industrial engineering how much pollution is produced as a byproduct of production. From epidemiology, we need to know how sensitive is the population. If everyone was a Superman, we'd need no pollution tax. We need to know from labor economics how much people value not being sick. How much do they value being healthy during a day? From GIS and geography, we need to know how many people are exposed to the pollution. And from economics, we need to know, do the, quote, victims, the 5 people who were exposed, do they have access to strategies to protect themselves? For example, folks, suppose for 5 cents they could have bought a mask. Does anyone here look cute with a mask on? In China, there's all these guys in Beijing with a mask on. They look cute. Wave to guys, gals, looking good. If you can buy a 5-cent mask to avoid $8 in damage, how much do you suffer when you're exposed to pollution? 5 cents. Did anyone understand what I just said? You're not a victim if you have cheap strategies to protect yourself. You can drop this class. You're not a victim. That was a joke. It's an interdisciplinary effort to measure each of these effects, and this is why I work at the Institute of the Environment. None of these fields by themselves can pull this off. It's like an orchestra of needing some strings, a drummer, and somebody playing the bass. So now let me say something interesting, and we're only down to 6 slides, but I'm aware of the time. Folks, does everyone remember that the profit maximizing firm chose on its own to produce 9 units of steel, and its profits was $152. Does everyone remember that excitement? Many young people are very interested in green accounting. I can now formally define these words in the context of our stupid model. Does everyone recall that based on our externality calculation, that society suffered $8 worth of damage of social costs? Damage and social costs are synonyms. Society suffered $8 of social damage when the firm produced, for each unit of steel, society suffered 8 units of damage. So folks, what's the old professor doing here? Why am I subtracting 72 from 152? Am I just showing that I'm the new Terence Tao? Why do I engage in this high-level mathematics? Don't read this. The question always to ask is, from society's perspective, what do you bring to the table? If there's a perfect substitute for me out there who could take my shoes, marry into my family, take care of my son, I bring nothing. This firm's value to society is the private profits it created minus what it destroyed in the process of production. To a good economist, we want to subtract the damage it created from the value it created. What $80 represents to me is the true social profit that this firm created. Folks, that 80 is greater than 0 means that what does an economist say about this factory? We shouldn't shut it down. But that yes, go ahead.
I have a question. Because you have already added the social cost into the function, but I think there's still some social benefit for this steel factor, because it also creates some employment which promotes the stability of society. Also, people don't want to go to the Wall Street and occupy it.
So
that's also the social benefit, and we should consider it and add it to the function too.
So he just said something very smart, but I don't want him to make a mistake on the exam. And you're being too smart. But let me, throughout this course, if a worker takes a job, we're going to assume that labor markets are perfectly competitive. If a worker works for $10 in a job, we're going to assume that if she were, unlike our Appalachia example at the start of class, if this worker were fired, that she could, at 0 cost, find another job at her reservation wage. You're being too smart. I want you to erase from your mind what you said. Workers face perfectly competitive markets. Let me make sure everyone understands. If UCLA fired me tomorrow, in our model, we're assuming that at 0 cost, I could move to USC. So we're assuming for the robots and workers who work at this factory that if this factory shrinks, they don't suffer. Folks, does everyone understand what I said? He is saying something very smart, but he's making the model too complicated. Do you understand what I just said? We should talk after class, but we want to assume there's perfect competition in the factor markets so that the issue he raised doesn't rise. Let me explain what he was saying. He was saying, Professor, if this steel factory is in Appalachia, and if because of the pollution tax they fire some workers, and if those guys then go home and shoot themselves and shoot their families, this is a tragedy. We have ruled out that these guys are going to do that. They can cautiously find another job at the same wage. That's what the assumption of perfectly competitive markets means. There's no unemployment. He was saying in a market, in a model with unemployment, there can be social benefits of a firm keeping workers on the job. And he's correct about that. But by making a perfectly competitive markets assumption, we're ruling out unemployment. We got to simplify the model to be able to solve it. Folks, let me go back to where I was. We define green accounting, the private profit to the firm minus the damage it caused to society. This is the real value added. Let me give you a fun example of this. Folks, when Saudi Arabia sells oil, it collects profit. But there are economists at Stanford University trying to quantify this. What is an unintended consequence of damage to Saudi Arabia when it sells oil? What is an externality it's imposing on itself? I'll let you guys ponder that. This course really stinks. All right. So for those of you who have taken a course in intermediate micro, how many of you have heard the words Pareto planner before? All right, well. So suppose that there was a wonderful human being who thought about, let's do it like this. I want to write down one more profit problem. Folks, at the start of the day, we saw that the firm maximizes this equation. Its profits, price times quantity, minus its costs. We all agreed that the firm ignored the damage that it imposed to the environment. Again, why did the profit maximizing firm ignore the environmental damage it imposed on society? Because it had no incentive not to. Folks, a benevolent planner would care about the profit from the steel factory, but she would also care about the damage it causes to society. So while a profit maximizing firm would maximize profit, a benevolent planner would maximize profit minus damage. Is everyone comfortable with that idea? We can now plug in, substitute this in for profit. That's this equation here. Why is the old professor substituting in minus 8 times Q for damage? Because that's the externality. It scales up with output. Folks, rewrite this calculus problem, collect terms, subtract this from this, and solve. The social planner chooses not to set Q equal to 9, but set Q equals to 7. When you internalize the externality, you want the steel factory to still produce a positive amount, but to produce less. Questions here, and I'd ask you to work through this. Folks, some new ideas. We're down to 4 slides before we wrap up class. The top is clipped. That says private property and public property. The externality caused by the steel factory exists because the capitalist firm, in its pursuit of its own profit, and everyone say money, 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 it perceived a zero price for the air and the water that it used. So folks, what would a libertarian economist say is a way to solve this problem? So one way to solve this problem is for government to have a pollution tax equal to $8. What would a libertarian say would be another way to solve this problem? Privatize the air and water and make the factory pay. So the factory has to pay for labor and robots. If it had to pay for the air it used, folks, if you were a factory owner and if you had to pay for clean air, what investments might you make as a cost minimizing business person? Would you still have a dirty factory? You'd at least look at the numbers and bring in a consultant to take a look. So as we talked about in our first class, the air and the water are public property. These are common resources that nobody owns. And so this firm is creating the tragedy of the commons. And let's see if we have a slide on Blinky the three-eyed fish. Let me do Blinky the three-eyed fish in the context of this slide. Folks, how many of you remember Blinky the three-eyed fish from The Simpsons? So in the context of today's lecture, how did that happen? So Blinky, for those of you who don't watch The Simpsons, there is a nuclear power station in Springfield. It provides many jobs and it produces cheap electricity. An unintended consequence of its production is that the water is polluted with radioactive water, and Blinky the three-eyed fish now exists. And this is supposed to be a symbol to righteous young people of the dangers of capitalism and of unregulated society. So how did this occur? I thought that was a hand. He's just combing his hair. No
perceived cost.
No perceived cost to the nuclear plant. So water's just public property? So it is this slide. So we might as well just read this slide since you guys are bored and I want to get out of here. The steel firm is stealing from everyone. It's stealing. If there was no government, it would get away with this crime. If the air, in the case of the steel factory, was private property, then the firm would have to pay for it and would have the right incentives to economize for it on its consumption. So this is an example of a deviation between society's goals and a free market firm's goals, and the positive role that government can play in solving a pollution problem. So folks, Paul Krugman, how many of you have heard of Paul Krugman? He's the Nobel laureate in economics. He writes for the New York Times twice a week. So I just revealed that none of you read the New York Times. Really. Be careful what you say to me. One way to deal with negative externalities is to make rules that prohibit or at least limit behavior that imposes especially high costs on others. That's what we did in the first major wave of environmental legislation in the early 1970s. Cars were required to meet emission standards for chemicals that cause smog. Factories were required to limit the volume of effluent they dumped into the waterways. And this approach yielded results. America's air and water became a lot cleaner in the decades that followed. We're going to talk about this idea. So notice this slide combines two ideas. It combines talking about a change in the rules of the game, and it talks about evidence, evaluating whether there's a causal effect of changing the rules of the game on environmental outcomes. Folks, in the 1970s, America had terribly dirty air and water. How many of you have parents who were in Southern California in the 1970s? Ask them about the orange days that were almost on a daily basis. So some of the issues, yeah, just two more slides. Some of the issues we're going to be talking about is when government steps in. Our next lecture is going to start to be about government. When government steps in to solve a pollution externality, whether it's a steel factory, whether it's a nuclear power plant, whether it's dirty cars, what is the intended consequences of the regulation? What are the unintended consequences? And folks, very important to me and my life's work, how do we judge when regulation has been effective at achieving our goals? Let me ask a question there, since we are almost done. Yeah, that's boring. Stay here for a second. A major question in modern social science, and you're going to deal with this in homework 1, is how do we know what causes are effective? Folks, how should professors' teaching be evaluated at UCLA? How should UCLA figure out who are the good teachers? I've never won a teaching prize. I never will. How do you currently evaluate teachers? You fill out your forms, and a select sample of folks do. Angry guys fill them out, and a couple of weirdos. I never filled out any of these things. I don't vote, don't do any of these things. It takes time. But folks, what's the right way to evaluate a teacher? The key question is, who would you have been had you not taken this class? We won't know for 30 years. And so it's a very interesting question how when you meet a successful person in their 50s, who deserves credit? Is it just the parent and that guy? Or was it certain teachers along the way? And so when you try to tease out causality, when the production function is complex, how do you know when we see air pollution progress, when you see a successful student, who deserves credit and how do you know it? And so that's one of the fundamental inference issues in modern statistics. And that is the causal effects question, which you'll be wrestling with in homework 1. So, questions that we're going to be talking about when we do government, and this may be our last slide. We started today on Appalachia. Who wins and who loses if we tackle the challenge of climate change? When we acknowledge that there's costs and benefits from environmental policy, how do we define what the words good environmental policy? What role do economists play in helping policymakers to design good policy? Do policymakers care what we have to say? And how this is, I don't know why this is here. That's important to me, but you shouldn't care. Folks, let me show you, it is still 10:07. Let me show you two things in homework 1. I want folks working in study groups. Alrighty. So homework 1 starts with some data. Somebody named Bertha has collected some data, perhaps related to today's lecture, for 3 different people called A, B, and C. And folks, read questions carefully and be careful what emails you send the professor. Send me smart things. You get some data here related to one of our slides on sick days and pollution days. And you guys are going to be forced to think a little bit about what inferences you can make about the sickness production function. So in the slides, there was a beta 0 and a beta 1. I don't want to hear dumb things about notation. Learn to think abstractly. But this is another linear production function. You guys got to think about its properties. And I strongly encourage you to click on any links you're given. This is a link from the London School of Economics where Alan Manning says some very smart things. For those of you who know some advanced mathematics, try to read the whole thing. For those of you who feel unambitious and don't care, just read the first page. But I'm especially interested in talking to folks who read the whole thing, because it gets harder and harder. In question 4, we then move from Bertha and to Jane. Folks, D is a different person. I don't want us to receive any dumb emails of what's a D. It's not your grade. It could be your grade. That's up to you. D is Dino, dinosaur, Dubo. It's a person. For this person, you see his or her, whoever D is, over time, you see his sickness and pollution exposure. So question 4, Jane has collected different data than Bertha. I want you guys thinking about who has a more compelling research design for estimating this function. And we will see what you guys have to say. Then we turn to a factory that makes sneakers. And folks, I want to give you one hint to the sneaker factory. And I want to teach you a deep idea from modern mathematics. If 10% of UCLA students take a course with Matthew Kahn during their years at UCLA, and if there's 2,000 students at UCLA, how many students end up taking my class in expected value? If 10% of all students take my class and UCLA has 2,000 students, can everyone multiply 0.1 times 2,000 and get 200? Take that as a hint for this question. And so, yeah, so this actually correlated with what we did. And that's, so very good. We are done. I'm going to stick around. Have a good day.